everyone, this is lesson 1.5, Describe Angle Pair Relationships. Today you're going to learn how to use special angle relationships to find angle measures. So some of these terms might be a review, and some of them might be new. Complementary angles are two angles whose measures have a sum of 90 degrees. Each angle is the complement of the other, so that's how you would say that. So for example, if one angle measure, let's draw an angle. Let's say this angle measure is 70 degrees, and you have another angle over here whose angle measure is 20 degrees. That's 20 degrees. Then you would say that those are complementary because they add up to 90. You can also have angle pairs that have the same vertex that add to 90. So for example, if you have a right angle, you draw a little box there to denote that it's a right angle, 90 degrees. But then you have a ray going through it. And let's say it makes 60 degrees and 30 degrees. Then you would call those two angles, the 60-degree angle and the 30-degree angle, complementary. And the relationship is that the measure, we can say, let's call this angle 1 and this angle 2. We would say the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So that's complementary. Supplementary angles are two angles whose measures have a sum of 180 degrees. Each angle is the supplement of the other. So one way to make sure that you're getting them straight is complementary starts with C, and that comes before, in the alphabet, that comes before S does. And on the number line, 90 comes before 180 does on the number line. So you can match them up that way. So complementary comes before supplementary. So examples of supplementary angles are, let's say you have an angle measure, an obtuse angle measure. Let's say this is 130 degrees. Let's call it angle 1. And then you have an acute angle. That would be 50 degrees. Call it angle 2. And if they both add up to 180, then they are supplementary. So the measure of angle 1 plus the measure of angle 2 equals 180. Okay, you can also have them together as to form one angle. So if you, let's take the same angle, actually let's take different angles. And if you add them together, that's 180, so that's a line. Let's start off by drawing a line. And then let's draw a ray going that way. Let's say it makes 70 degrees over here. So then it would make 110 degrees over here. So those are supplementary angles. Adjacent angles are two angles that have a common vertex and a common side, but no common interior points, which means basically that they don't overlap. So here's an example of adjacent angles. So you have an angle here, and then you have another angle that shares this side and has the same vertex, but it goes over there. So let's call this angle 1 and angle 2. I'm not trying to say that they are complementary, that they add up to 90. They can be anything. These are just adjacent because they share an endpoint and they have a common side. So they're side by side. And also, so what we just did with the adjacent angles is we named what these two angles are. So these two would be adjacent angles because they're sharing a side and they share a vertex. Now they can be complementary or supplementary, but they don't have to be. So you can write that in your notes too. Can be supplementary or complementary or neither. I'll type it for you. Can be complementary, supplementary, or neither. All right, the specific type of adjacent angles whose non-common sides are opposite sides, whose non-common sides are opposite rays, is called a linear pair. So our opposite rays, that means it forms a 180-degree straight line. So that is a linear pair then would be what this is. So this is, we can abbreviate it as LP for a linear pair. This is an example of a linear pair. Is a supplementary adjacent angle. And so a diagram for it, you can have a line, you can have a ray going out that way, 1, 2. So here the measure of angle 1 plus the measure of angle 2 equals 180. So it's a supplementary angle that is adjacent. So we'll write that in our notes. Supplementary angle that is also adjacent. So not all supplementary angles are linear pairs, but all linear pairs are supplementary. And then vertical angles are two non-adjacent angles, that means they're not touching, formed by two intersecting lines. So you're going to see this a lot if you have a line, and then if you have another line, they're intersecting. Here is the vertex. So the vertical angles, vertical you can also think of as opposite. So here, if I number these angles going around the vertex, there are 4 angles. So angle 1 and 3 would be vertical angles because those are opposite, and angle 2 and 4 would be vertical angles. So let's say this is 110 degrees. So if you go around, if this is forms a line, so this would be 70 degrees. Okay, and then if we keep going, if this is 70, then this has to be 110. And if that's 110, then angle 3 has to be 70. So it is true that vertical angles are congruent. So that means angle 2 and 4 are congruent, and angle 1 and 3 are congruent. Vertical angles will always be congruent. So we could say the measure of angle 1 equals the measure of angle 3, and the measure of angle 2 equals the measure of angle 4. Okay, so those are vertical angles. Let's do some practice. It says use the diagram to name examples. Angle 2 and 4 form a right angle. No, angle 2 and 3, sorry. So here is a right angle. So let's name some angle pairs. Let's say our complementary angles. So complementary angles would be, well, here the only one we know for sure is 90. Is this one marked? The other ones you can't say for sure. Definitely know angles that add up to 90 over here. So here, angle 2 and angle 3 are complementary. Okay, how about the supplementary angles? So 4 and 5, we'll just make a list. Supplementary. So 4 and 5, those would be supplementary. Let's see, 1, 2, and 3. Like, add all those up, those form 180 degrees. 6 and 7. I'm just going to name pairs that are like pair, so 2. And then over here we've got a bunch. So we've got 7 and 8, 8 and 11, 11 and 10, and 10 and 9. So 8 and 9, 8 and 11, 11 and 10, and 10 and 9. Okay. And then you also have vertical angles. So in this diagram, the only 2 vertical angles are 3 and 5. And I'm just going to mark them like this. So those are vertical angles. VA for vertical angle. And like 1 and 4 are not vertical because if you look, the angle formed by 4 is this line and that line. which comes this way and that way, but the opposite angle of 4 would be 1 and 2 together, not just angle 1. So 1 and 4 are not vertical angles. 1 and this entire angle are vertical angles. So, but over here, 8 and 10 are vertical angles, and so are 9 and 11. Okay? Moving on. Tell whether the indicated angles are adjacent. So BAC and CAD, BAC, CAD, yes, those are adjacent because they share AC and vertex A. How about this one? EFG and HGF. No. They do have this common side, but they don't share a common vertex because remember the vertex is the letter in the middle. And then JNM, and LNK. No. Those are vertical angles, and by definition, vertical angles are not adjacent. Number 4, name a pair of complementary angles and a pair of supplementary angles. So if I did 55 plus 35, that would be 90. So complementary would be angle POQ and angle ROS. Those would be complementary. And then supplementary would be, there are different options for this one. You could say POQ, angle POQ, and angle QOS. Or you could say angle SOR and angle ROP for supplementary. Number 5, complementary, let's see. Well, it has to add up to 90. So 20 and 70 would add up to 90. So for complementary, I'll put it in this same line, is angle UTV and angle XYZ. And then for this one, it would be the 110 and the 70 add up to 180. So angle VTW plus angle XYZ. Next question. Angle 1 and 2 are complementary. Give the measure of angle 1, then find angle 2. So 1 and 2 are complementary, which means if I do 90 minus 52, then I get my answer for angle 2. So that would be 38. So 38 for this one. And then 90 minus, I guess I should show my work. 90 minus 76 would be 14 degrees. For this one, it says they are supplementary. So if I do 180 minus 52, we get 128. Here, if I do 180 minus 76, I get 104. All right, number 10. Find ABD and DBC. So here, if I know that this is a straight line, this is 180, and I know that this is already 90, then I have 90 left over. So this is also going to be a right angle. So I could say 2x plus 3x equals 90. That means 5x equals 90. And if I divide by 5 on both sides, I get x equals 18. So then if I plug that back in, the measure of angle ABD equals 2 times 18, which is 36 degrees. And the measure of angle DBC would be 3 times 18, which is 54 degrees. Okay, and let's do the last question. Last 2 questions. It says find the values of x and y. So I can't find y yet. I have to find x first because if I try to set these two equal to each other, since they're vertical angles, we'll have 2 variables. So first we'll need to use the fact that these are supplementary, so we'll add them up and equal to 180. So if I add those two up, 60 plus 9 is 25x, plus 5 equals 180. Subtract 5 over and get 175. So then x would be 7. So I found x, and then I'm going to plug x back into this equation. So 9 times 7 plus 5 would be 60. 3 plus 5, which is 68. And then I would set that equal to 4y, since these are vertical angles. Divide by 4 on both sides. So let's think that'd be 34 divided by 2 is 17. So y equals 17. Okay, and gotta do the same thing for this one. So add these up to equal 180. So that would be 8x and then minus 20 equals 180. If I add them up together first, and then add 20 over, so 8x equals 200. So x equals 25. If I plug 25 back in, that would be 6 times 25, which is 150. 150 minus 11 is 139. So I set 139 equal to 20y plus 19. I can use a different color other than red. Subtract 19. So that's 120 equals 20y. So y equals 6. Okay. So here there is an exit ticket in Polaris. Go ahead and try it out. And then once you're done with your exit ticket, you can move on to the homework 1.5. Thank you and have a great day.